so we are doing the Heart of Algebra. This would be part 3. So we're starting on page 10 of the text for Heart of Algebra. What we're going to do is we're going to start off with a review of what we've been doing so far by just looking at the 4 ways to represent a function. We've also done more. We've looked at domains and ranges, inputs, outputs. We've looked at y is a function of x is a function of y. We've looked at other things also, but this is the basis of what we've done for the first 9 pages. Okay, so there are 4 ways to represent a function. The first is verbally, so actually saying what the function is. The second is numerically by a table of 2 variable data, so we've seen both of these. Third is symbolically by an equation. And then 4 graphically, by a graph and a coordinate plane. So we've seen all 4 of these. For this next example, we're going to do all 4. Okay, so it says a pizza parlor charges $14 for a plain cheese pizza and $2.35 for each additional topping. The cost of a pizza is a function of the number of toppings. Express the function in each of the above 4 ways. Okay, so first of all, we have this, which tells you it's a function. So it says the cost of pizza is a function of the number of toppings. Okay, so we had a definition. So pizza is a function, cost of pizza is a function of the toppings or number of toppings. Okay, so we're going to have cost equals, then we're going to have something in terms of t. Okay, so cost is a function of toppings. So C for cost, which I should have said that, and T for toppings. Okay, so first of all, verbally, we really don't need to write this one out. I'm going to go ahead and just write it, but that's exactly what I had underlined here. I'll put a little more detail in there, but this is just writing out what the function is. So I'm just going to put the cost is $14 plus $2.35 for each topping. we extend our window, so if we would go to maybe 30 and 30, it's going to be different, or 100 and 100, it would be different. Okay, so make sure you know if it's going off of your graph, okay, that means it's going to keep increasing. Okay, so that's page 11. Next, we're going to find another piece of information given the graphs. So it says the function value f of a is a local maximum of f if f of a is greater than or equal to f of x for values of x near a. And the function value f of a is a local minimum of f if f of a is less than or equal to f of x for values of x near a. Okay, so let me just draw a quick picture of this. So let's say you have some graph here. Okay, you have an x value here and maybe f of x here. Okay, so you would have a point. Okay, x f of x. It says the value, let me change that to a. I should have used a here. So input a, you output f of a. It says the function value f of a is a local maximum if f of a is greater than or equal to f of x. Okay, so that means that this value, this f of a, is the highest point because it's greater than or equal to all these other values of x near a. Okay, so that means pick another value here, x. Okay, that means it has to be lower. Pick another value here, x. It has to be lower because it's greater than or equal to. Pick another value, x. It has to be lower. Okay, so this f of a is the highest point. That means it's the maximum. Okay, maximums normally have this, or local maximums will always have a picture like that. Okay, so you have a peak here. Local minimum is the same way, except it's changed to less than or equal to, so you'll have something like this in your minimum. Okay, so for an example, it says for the function below, label the local maximum and local minimums. I'm just going to draw a picture for that, and we're not going to do any specific points. We'll just look for the maximum and the minimum. So something maybe like this. Okay, this would be the local maximum. It looks like it's the highest point. Okay, notice it's not the absolute maximum because this is going to keep rising, but it's a local maximum, meaning all the points around it are lower. Okay, so this is a local maximum. This would be a local minimum. Okay, again, it's not the absolute minimum. You can see it's still lower here. Okay, but all these points around it are higher than that, so that would be a local minimum. Okay, so we have next example. It says graph the function f of x equals x cubed minus 4x squared minus 7 in an appropriate window. Find the local maximum and minimum values. Okay, so on your SAT, you're not going to be, I don't think you would be asked to graph something this complicated because you're not required to have a graphing calculator. So I would think that they would give you a picture like this, but you will have to do some graphing. So just keep that in mind. Probably not something this complicated. So we have x cubed minus 4x squared minus 7. Let's go ahead and try it in standard window. We'll see if it works. For your SAT, you're going to be given a picture of your graph, and then you'll have to find the minimum and maximum. Okay, you can see it's going off the page down here. I need to make my y minimum a little bit lower. So let's try y minimum at negative 20 and see if we get a good picture. That looks good enough. Okay, so our window, I'm just copying this picture, negative 10 to 10, and our y, I chose negative 20 to 10. And the picture looks something like this. Okay, so a little bit like that. So on your SAT, it might give you something like this, and it'll say, what is the maximum value? Okay, so first let's go ahead and pick it out. So here's maximum, here would be the minimum. I'm going to show you how to find these on your calculator. For your SAT, it'll probably have a grid, okay, and it'll be an exact point, or you'll have to estimate. Okay, but on your calculator, we can actually find the minimum values. So you're going to go to second trace, so you're going to calculate. Let's do the maximum first. Okay, we decided our maximum, which that is just lucky that the cursor landed there, but we decided our maximum was here. Okay, so we need to follow the commands on the calculator. It says go to the left or left bound. So we need to go somewhere to the left of this, which we are on the left. Now it says right bound, so we need to go somewhere to the right of our maximum point. Okay, so I'm to the right. And then your calculator says guess, which we're going to press enter. So what this calculator is doing is you're giving it parameters. So you're saying check between this bound and this bound. Okay, and spit out the highest value. Okay, so your calculator is just doing calculations back in this table, and it's trying to find the highest value between those two. Okay, so go ahead and tell it to guess, and it puts it to where we thought our maximum would be. X, that looks like it's 0. It's very close to 0. Remember, that is e to the -7 or 10 to the -7, which is basically 0, and -7. So this point is 0, -7. Okay, now we want to find this minimum. Same way, second, calculate, go down to minimum. Okay, we need to go to the left of our minimum, somewhere here. Now to the right of our minimum, somewhere here is fine. And guess. I got approximately 2.67 and -16.48. Okay, so let's go ahead and write out the information. Our maximum value is -7 when x equals 0, and minimum is -16.48 when x is 2.67, and those are approximate values. Remember, your calculator is just guessing. Okay, a couple more definitions. This is just from finding information from graphs. It says the function f is increasing if the values of f of x increase as x increases, and the function f is decreasing if the values of f of x decrease as x increases. Okay, so this means as we move along the x value, or x-axis, I'm sorry. So as x increases, if you have a rise, you have an increase. If you have a fall, you have a decrease. Okay, and this is as you move out this way. Okay, so it says for the function below, find the intervals on which f is increasing and which f is decreasing. Okay, again, I'm just going to give you a picture. Let's say we have some picture like this. Okay, you have a maximum, local max here, local minimum here. Okay, so as x increases, so as we move out this way, where is our increasing and decreasing intervals? So here you have a rise, so this would be increasing. Here you have a fall, again we're moving out this way, so this would be decrease. And then here you have a rise again, so this would be increase. Okay, so what we're going to do is we're actually, for the next example, going to do specific intervals there. Okay, so it says graph the function f of x equals x cubed minus x plus 39 in an appropriate window. Find the intervals on which f is increasing and on which f is decreasing. Alright, so we want to graph this function. So this is x cubed minus x plus 39. We definitely need to change the window. I think we graphed this before, but I'm not positive. I think -10 to 10 will work. Y minimum, let's stick with -20. Y maximum, let's go up to 50, see if that works. We'll see where that gets us. Okay, that looks good. That's good enough. For this graph, which let me pull this up a little bit, looks like there's a minimum and a maximum. So maximum here, there's a glare there. Maximum here, minimum here. You guys see that? There's just a little bit of a fall here. Let's go ahead and copy this picture down. -10 to 10 was our X window. Y was, I believe, -20 to 50. Okay, and then our picture looks like this. Okay, there's that. Something like that. Okay, so we have a minimum here, and I'm sorry, a maximum here and a minimum here. Okay, you know how to find those on your calculator. I'm going to go ahead and just give them to you. So this point is negative 0.58, 39.88. And this is approximately, your calculator is guessing. And then the minimum is 0.61, 38.61. Okay, so there's our minimum, there's our maximum. We're trying to find intervals of increasing and decreasing. So let's do increasing intervals first. Okay, so we have an increase here. Remember, it's as you move in the positive direction of your x's. So you have a rise here, this would be increasing. Also, you have increasing on this part, you have a rise here. Okay, so increasing, we're looking at the x values. We would start at, it looks like negative infinity, because this is going to keep going down. You can evaluate to negative infinity over here. So this would be negative infinity to, I'm looking at the x's, to negative 0.58. Okay, I'm going to leave this open parentheses. I'll explain that in a second. You also have this x is 0.61, and then it's also off to infinity. Okay, because it's going to keep increasing here. For decreasing, we just have one interval set. It looks like from here to here. So you have a fall there. So using the x's, I have 0.58 to negative 0.58 to 0.61. So from here to here, you have a decrease. Okay, so negative infinity to here, increase. From here to here, decrease. And from here to infinity, increasing again. So you should, after writing out all these intervals, cover the whole x-axis. Okay, why did I leave these points open parentheses? Okay, I believe that on these 2 points, okay, it's neither increasing or decreasing because it's your maximum or your minimum. Okay, some people say no, it's increasing and decreasing, so they would have closed brackets. Okay, it doesn't matter. If you use open or closed, it's still correct. Okay, I always use open. Okay, if you use closed, it's still correct. Okay, one more example. It says the height of a ride at an amusement park is given by h of x equals x to the fourth, negative x to the fourth, plus 7x cubed minus x squared plus 10x minus 1, with x being time in minutes. Use your graphing calculator to graph the function and to answer the questions below. Okay, so this would be very much like something on the SAT exam. Again, you're probably not going to have to graph something this complicated because they don't expect you to have a graphing calculator. Okay, but this is a great tool to have, and I'll explain to you why graphing calculators would definitely help you, especially in solving equations later. Okay, so we have negative x to the fourth plus 7x cubed minus x squared plus 10x minus 1. Okay, window, let's go ahead and use negative 10 to 10 will be fine. And let's look at this problem first, because I think that this window will be better if we look at it. Input is an x value where it says x is time in minutes. So input is x and this is time or minutes. Okay, your output, it says the height of a ride. So this would be h of x. And this is going to be in, it doesn't say what our unit is, so I'm just going to put height here. It could be feet, meters, I'm not really sure. It doesn't say, does it? No. Okay, so going back to our window, our input is time. You can't have negative time, so let's go ahead and change the x minimum to 0. So you have 0 to 10. I think that should be plenty. And then the x minimum, again, you can't have negative height. Okay, negative 10 feet doesn't make any sense. So let's go to, this is an amusement park ride. Let's go to like 500 feet maybe. I'm not really sure if that'll work, so let's try it. Okay, so it looks like the ride, you increase, you increase, you increase, and then you fall fast. Okay, so there's the amusement park ride. So let's go ahead and draw this picture. We did 0 to 10 and 0 to 500, and it looked like this. So slow increase at first, then a faster increase, and then a fast fall. Okay, number 1, it says, what is the maximum height of the ride? So that's going to be this point here. So we want to find the maximum height. So how high does this graph or this amusement park ride go? So again, I went to second trace. Left bound, I want to go to the left of the maximum, which is the very top point. Then I'm going to go to the right of the maximum, and then I'm going to guess. And it says the maximum is 5.24. This is the point. 277.17 approximately. Okay, so the maximum height, which I'm just going to write, max height, is 277.17. I don't know if it's feet or not. I'm going to put at since we know this is time. At x equals 5.24 minutes. Okay, so after 5 minutes of this ride, you're going to hit the maximum point. Number 2, at what times would the ride be falling? Okay, so anytime we have a decrease. So the decrease would be here to here. Okay, so that would be 5.24 to here. Okay, so I'm just going to put 5.24 and on. Okay, so once you've hit 5.24 minutes, you're going to be falling the rest of the ride. Number 3, when does the ride reach a height of 100 feet? There will be 2 solutions. Okay, so how can we find this? So we need to find 100 feet here. So an easy way to do that is to just graph 100. So remember, this is a constant function. Okay, so this should be a horizontal line. Okay, so now we have 2 graphs. We want to find where they intersect, which you can see is this point and this point. Okay, which we've done this with our calculator. We've used the intersect function. Okay, so first curve, I'm going to hover around the first intersection point, second curve, enter, and then I want it to guess. Okay, I'm going to go ahead and draw that in. So this is 100 feet approximately here. This point is approximately 2.66 100. And then we want to find this point. Again, we're going to use the intersect feature. Okay, we're going to go over to this point and hover. Okay, enter, enter, guess. It looks like 6.74 100 approximately. Okay, so it says, when does the ride reach a height of 100 feet? So at 2.66 minutes and 6.74 minutes. Okay, and it does say it's in feet, so we can go ahead and fill in feet here. Okay, and then number 4, how long is the ride? Okay, so the ride ends as soon as you hit the ground here. Okay, so we need to find this point here. Alright, so what we're going to do is we're going to use our calculator again. Okay, which I'm going to come back up on the graph. Okay, and we want to find this point here. We could go ahead and graph 0 and just do an intersect, but this is also the x-intercept. Okay, so let's go ahead and go down. So I went to second, calculate, and I'm going to go down to 0. Okay, and I want to be on the left of, I'm looking at this 0 here, so where x is 0. I'm sorry, y is 0. So over here. Okay, now I want to go to the right and guess. Oh, no. We actually need to change our window. So for that, let's just go ahead and graph 0 again. Okay, so I just graphed 0, so you should see just a thin function here. Okay, go to calculate, we'll do intersect. First curve, second curve you want to go to the 0 one. Should brings us to that one. I want to go to the other one. Okay, I'm going to just hover around this point here. When I did the 0, for that you need to have, it said no sign change. So I would need to go below, which I didn't want to change my window, so that's why I decided to go this route. Make sure you change your second curve to the x equals 0 curve. Okay, and then that is 7.050. Okay, so that's this point here. So how long does the ride last? About 7.0, sorry, rounded is 6. 7.06, this would be in minutes. Okay. Alright, so there is that. So we will go ahead and stop there, and we will continue with transformations of functions in part 4.